Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI-powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine you hire an AI to fix your code. It passes all tests, looks perfect, but a week later, everything breaks. Why? Because writing code is easy. Maintaining it over time is the real challenge. Today, we are diving into a paper called SWE-CI, evaluating agent capabilities in maintaining code bases via continuous integration by Jialong, Chen and Xander. And this paper tells a story most benchmarks completely ignore. Most AI coding benchmarks, like HumanAvel or SWE Bench, test one thing. Can the model fix this issue right now? But real software doesn't work like that. It evolves slowly, painfully, across months. The paper highlights something critical. 60-80% of software cost is maintenance. Yet, current benchmarks are like snapshots. One input, one fix, done. That means a messy hack and a clean architecture can look identical until the next change arrives, and then everything falls apart. So the authors introduced something new, SWE-CI. Instead of testing one-shot fixes, they simulate continuous integration loops, just like real teams. Here's the key shift. Instead of fix this once, they do keep evolving this code step by step over time. The system works like a loop: generate requirements, update code, run test, repeat. This is called evolution-based evaluation. Now, to measure progress, they introduce two important metrics. First, normalized change. It tracks how many tests improve or break over time, not just pass-fail. Second, EvoScore. This is the big idea. It's a weighted score where later iterations matter more. Why? Because good code isn't just correct early, it stays stable as changes accumulate. Think of it like building a house. Anyone can build fast walls, but only good design survives storms. Now here's where it gets really interesting. They don't use one agent, they use two agents working together. The architect, the programmer. The architect reads failing tests, finds root causes, writes high-level requirements. The programmer understands those requirements, plans changes, implements code, and they loop again and again, just like a real dev team doing CI/CD. Even the dataset is realistic: 100 tasks, real GitHub repos, approximately 233 days of history, approximately 71 commits per task. This isn't toy code, this is real-world evolution. So, what happens when we test modern LLMs? Three big findings. First, models are improving fast. Newer models consistently perform better, especially in long-term maintenance. Second, different models have different strategies. Some optimize short-term wins. Others focus on long-term stability. That's controlled using a parameter called gamma, which weights future iterations more. Third, and this is critical, most models still fail at avoiding regressions, meaning they fix something but break something else. The paper introduces zero regression rate, and most models score below 25%. Only a few top models cross 50%. So even today's best agents still struggle with stability over time. Let's talk pitfalls. Biggest pitfall: optimizing for passing tests early instead of writing maintainable code. This creates technical debt and it compounds with every iteration. Another pitfall: overloading the system with too many changes at once. That's why the architect is forced to keep requirements incremental. Limit to max 5 tasks per iteration. Practical tip: if you are building coding agents, separate planning from execution. That architect-programmer split isn't just design, it's what enables long-term stability. Also, always track regressions explicitly. Passing test isn't enough. You need to track what broke. So here's the big takeaway. We are moving from can AI write code to can AI maintain systems over time? And SWE-CI shows we are not quite there yet, but we're getting closer, and the next generation of coding agents won't just write code that works, they'll write code that lasts. If you found this helpful, hit like, subscribe and comment which AI system you want to build next. Stay sparked. See you in the next video.